By popular request, this is the Complete Land Navigation Masterclass. True navigation is a dying art, but it's the key to self-reliance and the skill that guarantees you can always find your way. Today we'll cover everything from fundamentals to advanced skills all in one video. I learned land navigation as a wildland firefighter, and these are the lessons that will give you unshakable certainty in your position. First, we'll learn the map, learn to read contour lines, plot your position with grid coordinates, and identify the hills, valleys, and ridges that will become your signposts. Next, we'll review the compass and master adjusting for declination, shooting an azimuth to find your bearing, and using a pace count to measure distance. And finally, we'll apply it all in the field, and you'll learn terrain association and match the map to the land, dead reckoning for low visibility, and resection to find your position if you ever get lost. This skill is built through dirt time, not screen time. Use this video as your reference, get a map and compass, and get out there and practice. If you put in the work, you'll never truly be lost again. Whether you're trekking through the wilderness, conducting a military operation, or preparing for an emergency, a topographic map is your guide to the terrain. Welcome to Introduction to Map Reading, where we'll explore the key components, symbols, and practical applications of topographical maps. So let's learn to navigate with confidence. Topographic maps are essential tools for land navigation, offering detailed information about terrain, elevation, and man-made features. They empower you to plan routes, analyze landscapes, and stay oriented in any environment. From military operations to outdoor recreation and emergency preparedness, map reading is a critical skill for success. To read a topographical map, you need to understand its four key components. Map scale. This shows the relationship between distances on the map and the real world. For example, a 1 to 50,000th scale means 1 centimeter on the map equals 500 meters on the ground. Smaller scales cover larger areas. Larger scales show more detail. Contour lines. These brown lines connect points of equal elevation, revealing the shape of the terrain. Closed lines indicate steep slopes. Wider gaps show gentler terrain. Map, legend, and key. The legend explains every symbol on the map, from rivers to roads. Always check it to understand what you're seeing. Grid system. A grid of squares provides coordinates for precise location identification. Use these to pinpoint positions or plan routes accurately. Topographic maps use color-coded symbols to represent features. Here's what to look for. Blue identifies water features like rivers, lakes, and streams. These are critical for navigation and resource planning. Green, vegetation such as forests or cultivated fields, showing where cover or obstacles might be. Brown, terrain features like contour lines and elevation points, helps you understand the landscape's shape. Black, man-made features, including roads, buildings, and boundaries, for identifying infrastructure. Red, major roads and significant features, like highways or landmarks, for quick reference. Memorizing these colors helps you interpret maps at a glance. Understanding map basics unlocks powerful applications. Route planning. Using the grid system and scale to plot efficient paths and avoiding obstacles like steep hills or rivers. Terrain analysis. Study contour lines and vegetation to choose defensible positions or safe campsites. Navigation. Combine map reading with tools like a compass or GPS to stay on course in any environment, from dense forests to open deserts. Regular practice, reading maps, identifying symbols, and plotting routes builds proficiency and confidence. To master map reading, practice regularly with real maps in varied environments. Start with simple routes and progress to complex terrain. Be aware of challenges like outdated maps or poor visibility, and cross-check with tools like GPS when possible. Always double-check your scale and legend to avoid errors. With time, you'll read maps as naturally as a book. Topographic maps are your key to mastering any landscape. By understanding scale, contour lines, symbols, and grids, you can plan routes, analyze terrain, and navigate with precision. In a world of GPS and tech, the magnetic compass remains a timeless tool for navigation. Welcome to Compass Basics, where we'll explore the components of a compass, how to use it correctly, and practical tips to navigate any terrain. Let's find your way with confidence. A magnetic compass aligns with Earth's magnetic field, providing a reliable way to navigate when technology fails or batteries die. Whether for military operations, outdoor adventures, or emergency preparedness, understanding compass basics is essential for staying on course in any environment. During my time in wildland firefighting, I'd personally recommend the Ranger 2.0 Quad Compass. It's durable, accurate, and gives you just about everything you'd want in a good compass. To master a compass, you need to know its 5 key components. The magnetic needle. The red end points to magnetic north, while the white or black end points south, guiding your orientation. Compass housing. This rotating dial contains degree markings from 0 to 360 degrees and orienting features to align with the needle. Direction of travel arrow. This fixed arrow on the base plate shows the direction you want to go. Orienting arrow. Inside the housing, this arrow is used to align with the magnetic needle for accurate bearings. Base plate. The flat base includes measurement tools like rulers and direction indicators for precise navigation. Using a compass correctly starts with proper holding technique. Hold the compass flat and level in your palm to allow the needle to move freely. Keep it at chest height for easy reading without straining. Ensure the needle can swing without obstruction. Check for stuck needles when you do this. Stay away from metal objects, like knives or vehicles, which can cause magnetic interference. A fun experiment that you can do with this is actually place your phone next to it and watch as the needle deviates, which is why you should keep the compass away from electrical devices like phones or radios, which will disrupt the needle's alignment. This might seem insignificant, but the reality is a phone that is too close to your compass can throw you off anywhere from 1 to 5 degrees. Basic orientation with a compass involves 3 steps. Magnetic north versus true north. Understanding magnetic declination, which is the difference between magnetic north and true north, which varies by your location on the globe. Check your map for a local declination angle and adjust accordingly. Taking a bearing. Point the direction of travel arrow at your target, like a hill or tree. Rotate the compass housing until the magnetic needle aligns with the orienting arrow. The degree reading at the index line is your bearing. Following a bearing. Hold the compass level and turn your body until the magnetic needle aligns with the orienting arrow. Walk in the direction of the travel arrow to stay on course. To master compass use, you should be practicing regularly to build it as a muscle memory and to build confidence. You should be starting in familiar areas, taking bearings to landmarks and following them accurately. Combine compass skills and map reading for precise navigation. Be aware of challenges like dense terrain or magnetic interference, and double-check bearings to avoid errors. Whether you're hiking, patrolling, or surviving, a compass keeps you oriented when it matters most. A magnetic compass is your key to navigating any terrain. By understanding its components, mastering its proper techniques, and practicing orientation, you can move with confidence in any environment. Navigating from point A to point B sounds simple, but in the field, it's a skill that demands precision. Welcome to Basic Route Planning, where we'll explore how to combine map reading, terrain analysis, and tactical know-how to move efficiently and safely. Route planning is a critical navigation skill that ensures you reach your destination while avoiding hazards and saving time. Whether you're hiking, conducting a military patrol, or responding to an emergency, a well-planned route reduces errors and boosts mission success. Let's break down the process, factors, and tools to get you there. The route planning process follows 6 clear steps. Identify start and end points. Pinpoint your starting location and destination on a topographic map for clarity. Study terrain between points. Analyze contour lines, vegetation, and features like rivers or hills to understand the landscape. Consider obstacles and hazards. Identify barriers like streams or steep slopes that could slow or endanger your team. Select primary and alternate routes.
Choose a main route for efficiency and at least one backup for unexpected issues. Calculate distance and travel times. Use the map's scale to measure distance and estimate time based on terrain and pace. Identify checkpoints and landmarks. Mark recognizable features, like a bridge or a hilltop, to track progress and stay oriented. Choosing the right route also depends on 5 key factors. Distance. The shortest path is not always the best. A longer route may be faster or safer if it avoids obstacles. Terrain. Consider slopes, obstacles, and vegetation. Steep hills or dense forests can slow you down. Weather. Rain can flood streams or create muddy trails, so check forecasts and plan for conditions. Concealment. In tactical scenarios, avoid skylines or open fields to stay hidden from threats. Resources. Identify water sources, potential shelters, or resupply points to sustain your journey. Unanticipated obstacles can also complicate your route. Water crossings. Rivers, streams, or swamps may require detours or equipment like ropes for safe passage and may not be present on your map. Elevation. Steep climbs increase time and energy. Opt for gentler slopes when possible. Vegetation. Dense forests or thick brush can hinder movement. Look for trails or open areas. Man-made obstacles. Roads, fences, or buildings may block paths or expose you to observation. Weather impact. Seasonal changes like snow or flooding can alter routes, so plan for contingencies. Navigation aids will keep you on course. Checkpoints. Use recognizable terrain features like a ridge or road crossing to confirm your position. Back bearings. Take reverse compass readings to verify your location by checking landmarks behind you. Handrail features. Follow linear features like rivers, roads, or power lines to guide your path. Catching features. Identify large features like a mountain or lake to stop you if you stay off course. Documenting your route ensures everyone's on the same page. You should be sketching the route on a map and marking checkpoints and hazards. You should also be listing key terrain features and compass bearings for each leg. Calculate distances for each segment and the total route using the map's scale. Estimate travel times factoring in terrain and conditions. And you should also be briefing all of your team members on the primary and alternate routes to ensure clarity and coordination. Route planning is vital for hiking, military operations, and emergency response. You should be practicing plotting routes on topographical maps and test them in the field. Watch for challenges like outdated maps or unexpected obstacles, and always have alternate routes ready. Combine map reading, compass skills, and terrain analysis to navigate with precision. Basic route planning is your foundation for safe and efficient navigation. By following the planning process, considering key factors, and using navigational aids, you can conquer any terrain and reach your goal. In navigation, pinpointing an exact location can mean the difference between success and failure. Welcome to Understanding Grid Coordinates, where we'll explore how grid systems provide precise location references for military, civilian, and emergency operations. Let's zero in on the details. Grid coordinate systems provide precise, universal references to identify locations on Earth. Whether you're calling in an airstrike, planning a hiking route, or coordinating a rescue, grid coordinates ensure clear communication and accurate navigation. The Military Grid Reference System, or MGRS, is the go-to standard for precision, and today we'll break down how it works and how to use it. Several coordinate systems are used for navigation. MGRS, Military Grid Reference System. This primary military standard is designed for precise positioning around the globe. UTM, or Universal Transverse Mercator. This is the civilian equivalent to MGRS and is widely used in mapping and GPS. Latitude and longitude. A traditional degree-based system used for global navigation, but less precise for small areas. Local grid systems. Region-specific grids tailored for local use, often in urban or national contexts. The MGRS is favored for its accuracy and ease of use in tactical and operational settings. However, UTM, as it's a civilian equivalent, is more widely used amongst civilian populations around the globe. The MGRS format breaks down into 3 parts. Grid Zone Designator. This identifies a large area, like, quote, 18S, covering a specific region of the globe. 100 kilometer square ID. 2 letters, like, quote, UJ, pinpoint a 100 kilometer square within the grid zone. Numeric coordinates. These are eastings, horizontal, read right, and northings, vertical, read up, giving a precise location within the square. MGRS coordinates vary in precision depending on the number of digits. For a 10-digit number, it's accurate to within 1 meter, and it's ideal for pinpointing exact positions like a building or a vehicle. 8-digit numbers are accurate to 10 meters and are suitable for small areas like a campsite. 6-digit numbers are accurate to 100 meters and are good for general locations like a hilltop. 4-digit numbers are accurate to within 1,000 meters and are used for broader areas like a valley. Choose the precision level based on your mission's needs. Plotting coordinates accurately follows 4 steps. Identify the correct grid square. Use the grid zone designator and 100 kilometer square ID to find the right square on your map. Read right, then up. For numerical coordinates, read eastings, right, first, then northings, up. For example, 1, 2, 3, 4, 5, 6 means 1, 2, 3 units right and 4, 5, 6 units up within the square. Use a grid reader or ruler. A grid reader or ruler ensures precision when pinpointing coordinates on the map. Verify location. Cross-check the plotted point with terrain features, like a river or hill, to ensure it makes sense. Grid coordinates are vital for precise communication, sharing exact locations for operations, rescues, or meetups. Navigation planning, plotting routes or checkpoints with accuracy. Search and rescue. You can pinpoint stranded individuals or critical sites. To master grid coordinates, you should be practicing plotting on real maps and cross-referencing with tools like GPS. Watch for challenges like outdated maps or misread digits, and always double-check your grid zone and coordinates. Grid coordinates are your key to precision in navigation. By mastering the MGRS or UTM format, understanding precision levels, and practicing plotting techniques, you can communicate locations and navigate with confidence. Reading a map is more than spotting symbols. It's about unlocking the secrets of the terrain. Welcome to Advanced Map Reading, where we'll dive into contour analysis to predict terrain difficulty, identify tactical positions, and plan efficient routes. Let's master the landscape and navigate with precision. Advanced map reading goes beyond basic symbols to interpret terrain through contour lines. This skill helps you predict challenging terrain, spot strategic positions, and plan routes that save time and energy. Whether for military operations, outdoor adventures, or emergency planning, understanding contours is key to mastering any environment. Contour lines are the heart of terrain interpretation. Here are some fundamentals. Contour intervals are the vertical distance between adjacent contour lines, like 20 feet or 10 meters. This will be noted on the map that you're using. Index contours are where every fifth line is bolder, marked with elevation numbers for easier reference. Intermediate contours are thinner lines between index contours that show smaller elevation changes. Depression contours are marked with downward pointing tick marks. These show low areas like basins or craters. Contour lines reveal terrain shapes. Steep terrain is going to be indicated by closely spaced contours indicating rapid elevation changes like cliffs or steep hills. Gentle slopes will be indicated by widely spaced contours, which show gradual inclines and are easier for movement. Ridgelines tend to be V-shaped contours pointing towards lower elevation marked ridges, high ground between valleys. And valleys are V-shaped contours pointing towards higher elevation, indicating valleys, often with streams. Saddles tend to be hourglass-shaped contours, which show low points between two peaks like a mountain pass. To read elevation, you should follow 4 steps. Find a known elevation point. Locate a spot elevation or index contour with a marked height. Count the contour lines by moving up or down from the reference point, counting each contour line crossed. Multiply by the contour interval is when you multiply the number of lines by the interval to calculate elevation change. Use interpolation. For points between contours, you can estimate elevation based on their position. Advanced map reading has critical tactical applications, such as high ground analysis, where you'll identify hills or ridges for observation points or fields of fire. It's ideal for tactical positioning. For route planning, it allows you to avoid steep climbs or choke points by choosing routes with gentler contours. For water flow prediction, you can use V-shaped valley contours to show drainage patterns, which helps locate streams or avoid flooding. For slope assessment, you can evaluate gradients to determine if terrain is passable for vehicles or foot travel. You can take your skills further with these advanced techniques, like slope percentage calculation. You can measure the rise over run and multiply it by 100 to determine the steepness, which aids mobility decisions. You can also do a line of sight analysis, which uses elevation profiles from contours to check visibility between points and is critical for observation or ambushes. Terrain association allows you to combine contours with other map features like roads or forests to navigate accurately without GPS. Advanced map reading is essential for military tactics, hiking, and emergency operations. You should be practicing interpreting contours in varied terrains to build proficiency. Watch for challenges like outdated maps or obscured features and cross-check with a compass or GPS. Regular practice sharpens your ability to predict terrain and make smart decisions. Advanced map reading unlocks the landscape through contour analysis. By mastering contour fundamentals, terrain interpretation, and tactical applications, you can predict challenges, plan routes, and dominate any environment. In today's world, GPS navigation puts the power of satellites in your pocket, but it's only as good as your understanding of its strengths and limits. Welcome to Intro to GPS Navigation, where we'll explore how GPS works, its key functions, and how to integrate it with traditional navigation skills. The Global Positioning System, or GPS, provides precise location data anywhere on Earth, revolutionizing navigation for outdoor adventures, military operations, and emergency response. But GPS is not foolproof. It has limitations that require backup skills. By mastering GPS and combining it with map and compass know-how, you'll navigate with confidence in any situation. Let's start with basic GPS fundamentals. Satellite systems. Over 24 satellites orbit Earth, providing global coverage by sending signals to your device that are specific to GPS. Position accuracy. Under open skies, GPS is typically accurate to about 3 to 5 meters, pinpointing your location precisely. Coordinate formats. GPS supports formats like MGRS, UTM, and latitude and longitude for universal positioning. Power requirements. GPS devices rely on batteries, so you should always carry spares or a power bank to recharge. Signal requirements. A clear view of the sky is needed for satellite reception. Obstruction or jamming can disrupt signals. It's worth noting on the subject of jamming that in the Russian-Ukraine war, there have been many examples of soldiers or news reporters entering conflict zones and having their GPS showing them hundreds, if not thousands, of kilometers from the location where they actually are. In these types of scenarios, GPS becomes obsolete and traditional navigation tools become a necessity. Primarily, GPS devices offer 5 functions. Your current position, which displays your exact coordinates in real time, letting you know exactly where you are. Waypoint storage, so that you can save important locations like campsites or objectives for quick reference later. Route planning, which creates routes by linking multiple waypoints to guide you on your journey. track logging, which records your traveled path for analysis or backtracking, and navigation, which provides bearings and distance to your destination, keeping you on course. Effective waypoint management keeps your navigation organized. By creating waypoints, you're marking your current position or manually entering coordinates for a specific location. You can set up naming systems by using clear, meaningful names like campsite or rally point for easy identification. You can coordinate entry by inputting precise coordinates in MGRS or other formats, ensuring accuracy. Verification allows you to double-check entered coordinates to avoid errors. And you can also back up by writing down critical waypoints on paper as a backup in case your device fails. GPS enhances your ability to navigate, but it does not replace traditional skills. You should use GPS to verify your position on a map and compass. Plot your GPS coordinates on a paper map as a backup. Practice map and compass navigation regularly to stay sharp. Always carry a map and compass in case GPS fails, and learn to convert between coordinate systems, like MGRS to latitude and longitude, so that you have flexibility. GPS is an invaluable tool for route planning, pinpointing locations, and coordinating rescues, but practice is key. Test your device in varied environments and carry backups. Combine GPS with maps and compass skills to navigate confidently. Watch for challenges like signal loss or battery failure, and always verify your coordinates to avoid errors. GPS empowers you to move with precision, but it's only as good as your preparation. By understanding its functions, managing waypoints, and integrating with traditional skills, you can navigate any terrain well.
In the wild, a compass and a bearing can guide you through any terrain or visibility. Welcome to Compass Navigation with Bearings, where we'll learn how to take and follow bearings, manage magnetic declination, and navigate with precision. Let's point the way forward. Bearing navigation provides precise directional guidance, allowing you to move accurately in any environment, from dense forests to open deserts, even in low visibility. By mastering bearing types, techniques, and corrections, you can stay on course and reach your destination with confidence. Let's start with the fundamentals of bearings. A true bearing is measured from true north, the geographic North Pole, as shown on maps. A magnetic bearing is measured from magnetic north, where your compass needle points. Grid bearing is measured with grid north, aligned with your map's grid lines. And a back bearing is the opposite direction of your bearing heading, calculated by adding or subtracting 180 degrees. To take a bearing, follow these 5 steps. Point the compass direction of travel arrow at your target or desired direction. Hold the compass level and steady to let the needle settle. Rotate the compass dial until the orienting arrow aligns with the magnetic needle's red end. Read the bearing where the direction of travel arrow meets the dial's degree markers. Record the bearing and apply corrections like declination if needed. To follow a bearing, use these steps. Set your desired bearing on the compass dial by rotating it to the correct degree. Turn your body until the magnetic needle aligns with the orienting arrow. Walk in the direction of the travel arrow, keeping the needle aligned. Check the bearing frequently to stay on course, especially in rough terrain. Magnetic declination is the angle between true north and magnetic north, and it varies by location. An eastern declination is when magnetic north is east of true north. You would subtract the declination angle from your compass reading. A western declination is when the magnetic north is west of true north. Add to the declination angle in this case. Annual change. Declination shifts slowly over time, so check current values on your map. Local variation is when declination can differ within the same area, so verify local settings. You can enhance your navigation with some field techniques. Intermediate targets are when you can pick visible landmarks, like a tree or a rock, along your bearing to guide your path. Pace counting is when you can combine bearings with pace counting to measure distance. About 100 steps is roughly 100 meters on flat terrain. Triangulation is when you take bearings to 2 or more known landmarks to pinpoint your position on a map. Resection is when you take bearings to known points and plot them on a map to find your location. Accuracy also strongly depends on a few factors. Your compass quality. When you have a higher quality compass, it's going to give you more reliable readings. Metal interference is also important to keep in mind, so keep your compass away from vehicles, weapons, or electronics that disrupt the needle. Tilting error is when you are not holding the compass level, and thus will receive inaccurate readings. Parallax error. You should be reading the compass from directly above to prevent misalignment. Common errors include forgetting to apply declination corrections, reading the wrong end of the needle, allowing metal objects to interfere, and not facing the direction of travel when taking a bearing. Always double check your setup and surroundings. Bearing navigation is critical for military missions, hiking, and survival scenarios. You should be practicing taking and following bearings in varied conditions to build muscle memory. Even just going for a walk in the park with a map and compass can be a good way to get your footing. Combine with map reading and pace counting for precision. Watch for challenges like interference or low visibility, and always carry a map as a backup.
When landmarks vanish and visibility fades, Dead Reckoning keeps you on course. Welcome to Dead Reckoning Techniques, where we'll learn how to navigate using direction and distance from a known starting point, perfect for challenging terrains or low visibility conditions. Dead Reckoning is a fundamental navigation technique that tracks your movement from a known position using compass bearings and distance estimation. When landmarks are scarce or visibility is limited, think of fog or night or dense terrain, Dead Reckoning ensures you stay oriented and reach your destination. Dead Reckoning relies on 4 principles. Your starting point, which is when you're beginning from a confirmed, known position with a marked coordinate or landmark, as well as direction tracking, which maintains accurate compass bearings to stay on course. Distance measurement is using pace counting or time estimation to track how far you've traveled. Continuous plotting involves regularly updating your position on a map to monitor progress. Pace counting is the heart of distance measurement. Pace definition. 1 pace equals 2 steps. Left foot, right foot. Individual calibration. You should be determining your personal pace count over a known distance, typically 100 meters. You can map this out using your phone and simply count your paces to see how many steps it takes for you to walk 100 meters. Terrain factors. You should also be adjusting for slopes, vegetation, load, or fatigue, which affects your stride. Counting methods involve using pace speeds, tally marks, or counting devices to track your paces accurately. You should calibrate your pace with 5 steps. Measure a 100-meter course on flat, easy terrain. Walk at your normal speed, counting your paces. Repeat 3 to 5 times to find your average pace count, typically 60 to 70 paces for about 100 meters. Test this on various terrains like hills or brush to understand the differences, and then create adjustment factors for conditions like adding paces for uphill or dense vegetation. Maintaining direction is always going to be critical. Frequent bearing checks is when you're going to verify your compass bearing every 50 to 100 meters to stay on track, like trees, rocks, or mountains along your bearing to guide your path. Course corrections involve making small adjustments to avoid drifting rather than large corrections later. Terrain affects your pace count, so adjust accordingly. Uphill can add 10 to 20% to your pace count due to shorter strides. Downhill, you can subtract 5 to 10% as your strides will lengthen. Under heavy vegetation, you should add 15 to 25% for slower movement through brush. Sandy, soft ground adds 10 to 15% as it increases the effort to walk. Ice and slippery conditions can add 20 to 30% to account for cautious steps. Mark your starting position accurately on a topographical map and then draw a bearing line from your start point using your compass. You can then convert your pace count to map distance using the map scale. Mark your estimated position along the bearing line. Update your plot regularly to track progress and catch errors early. Errors can throw off Dead Reckoning, so watch for these. Your pace count drift. Recalibrate regularly and adjust for terrain. Bearing errors occur, so you should be checking your compass frequently and use intermediate targets. Fatigue effects include monitoring for tiredness and adjusting pace counts as needed. Environmental factors. You should account for weather, load, or terrain changes to stay accurate. Take Dead Reckoning further with advanced applications. Multi-leg navigation is when you chain multiple bearings and distances for complex routes. Your return navigation is when you use back bearings and reverse pace counts to retrace your steps. and position confirmation is combining with terrain association and matching map features to the landscape whenever possible. Dead reckoning is your lifeline when the world disappears. By tracking direction, measuring distance, and plotting progress, you can navigate any terrain with precision. When GPS fails and your compass is lost, nature itself becomes your guide. Welcome to Navigating Without Tools, where we'll learn natural navigation using the sun, the stars, and environmental clues to stay oriented in any wilderness. Let's rediscover the ancient art of finding your way from a time when a compass was not yet a tool at human disposal. Natural navigation is a survival skill that can keep you alive when tools fail or are unavailable. By reading the sun, stars, moon, and environmental signs, you can maintain direction and estimate position in any terrain. Whether you're stranded in the wild or operating without gear, these techniques provide reliable navigation with practice. In the Northern Hemisphere, Polaris, the North Star, points to true north. You can start by locating the Big Dipper, which is a bright, spoon-shaped constellation. You should try to find the two stars forming the outer edge of the Dipper's bowl. Then, draw an imaginary line through these stars to Polaris, which is about 5 times the distance between the two stars that form the outer edge of the Dipper's bowl. Polaris is a nearly fixed star, which makes it a reliable guide for nighttime navigation. During the day, you can use the sun and a shadow stick to find your direction. You can place a stick upright in the ground and mark the tip of its shadow. Then, wait about 15 to 20 minutes and mark the new shadow tip. Drawing a line between the two marks runs east to west, with the first mark closer to west. If you stand with the first mark to your left, you're facing roughly north. This method works best around midday and requires clear sunlight. Clouds and wind offer navigation clues as well. You can observe the prevailing wind directions, which are often consistent in a region, dependent on the time of year, to maintain a general bearing. Cloud formations like cumulus clouds forming over hills indicate terrain features as well. Moving clouds can suggest short-term wind direction. You can track their movement relative to landmarks. Learning local weather patterns to interpret these signs accurately helps a lot in determining a general direction of travel. Stars also shift with seasons, but their patterns remain reliable. Learning key constellations for your region, like Orion or Cassiopeia, which rotate around Polaris. You can note their positions at different times of night and seasons to estimate direction and time. For example, Orion rises in the east in early evening during winter, which can help you confirm your bearings. Practice observing seasonal changes to build confidence. Vegetation and geology provide natural navigation cues. Moss growth, for example, in the northern hemisphere, often grows thicker on the north side of trees due to less sunlight, but you can verify with other signs. During winter, snow accumulation melts faster on south-facing slopes, indicating the direction. For tree growth, trees will also tend to lean or have denser branches towards the sun, south in the northern hemisphere. This is a phenomenon in my particular region, where north-facing mountains will have more tree coverage, and south-facing mountains will have less tree coverage. For animal behavior, game trails or migration patterns often align with terrain features like valleys, oftentimes heading in the direction of water, thus guiding your path. This can be helpful as in most cases, in a true emergency, finding a stream or river and following parallel to its direction of travel can be a good way of finding civilization. You can also estimate distance and time using other natural phenomenon. We've discussed in previous lessons calibrating your steps, which tends on average to be about 60 to 70 paces per 100 meters on flat terrain to help you measure distance. The sun also moves roughly 15 degrees per hour across the sky, which helps estimating time. For shadow length, the longer the shadows in early morning or late afternoon can also help indicate time progression, meaning if you begin to familiarize yourself with the length of your shadow throughout the day, you can roughly estimate what time it is. It's important to note that this method is challenging to get a good feel for, because with seasonality changes, the length of your shadow will indicate different times in winter than it would in summer. Natural navigation is critical for survival, military operations, or backcountry exploration when tools fail.
Practice in familiar areas to learn local signs like wind patterns or vegetation. Test techniques in varied conditions, day, night, or during weather or season changes. You should always be cross-checking multiple indicators to confirm direction, as single signs can mislead. Navigating without tools taps into nature's wisdom. By reading the sun, stars, vegetation, and more, you can find your way in any environment. In hostile territory, staying unseen is as critical as reaching your objective. Welcome to Evasion Route Planning, where we'll learn to balance speed and concealment, choosing routes that keep you hidden while moving forward. Let's master the art of slipping through the shadows. Evasion navigation is about moving undetected through challenging environments, whether escaping pursuit, conducting covert operations, or surviving in hostile areas. By carefully selecting routes, using terrain to your advantage, and planning for contingencies, you can avoid detection. This skill is vital for military missions, survival, or high-risk escapes. Evasion route planning hinges on 4 key principles. Terrain masking. Use natural features like hills, forests, or ravines to block enemy line of sight. Avoid population centers and steer clear of towns, roads, or settlements to minimize civilian encounters and surveillance. Natural concealment involves leveraging dense vegetation, shadows, or dead space to stay hidden. We'll touch more on dead space in a moment. Plan at least 2 escape routes to adapt to threats or blocked paths. In some scenarios, it may be best to plan more than 2 escape routes. Dead space are areas hidden from observation. Think of something like a ravine or a depression in the landscape, or an alleyway in an urban area. On a topographic map, there's a few things that you can try to focus on. You can look for tightly packed contours or hachured lines indicating low areas. You should also identify terrain like gullies or wooded valleys that block enemy sight lines. In the field, you should be scouting out an area of operation as much as you can before proceeding with the mission to confirm these areas provide cover and adjust your route to stay concealed. You should be doing as much recon and intel gathering as you can so you can know your enemy's observation patterns. Study likely vantage points like hilltops or towers where enemies may be watching from. You should also be analyzing patrol schedules or sensor placements to predict surveillance gaps. Avoid skylines or open areas where you're exposed to spotting. Think of the ridgeline of a mountain. If you were walking right across the top of it, you'd be easily spotted from multiple directions. Plan routes through low ground or covered areas to exploit blind spots in their coverage. Timing is also always going to be critical for evasion. You should be moving during low visibility conditions like dawn, dusk, fog, or heavy rain to reduce detection risk. Consider UAVs and drones potentially using thermal imaging, and recognize the importance of trying to move as discreetly as possible at all times. You should be utilizing weather forecasts to predict conditions that obscure enemy sensors, like storms or cloud coverage. You should also be avoiding predictable movement schedules to keep enemy guessing. Don't move at the same time of day every day. Timing your moves with natural cover maximizes your concealment. Cache points and rally positions ensure flexibility. A cache point is a pre-planned hidden supply stash with food or equipment along your route to sustain long evasions. Mark them on maps with precise coordinates. You should also designate regrouping spots, or rally positions, in places like a concealed grove or building for your team to reassemble if separated. You should be planning multiple locations for redundancy and mark them clearly for navigation, but ensure that if a map that you have falls into enemy hands, it's not easy to distinguish what those points may be. Operational security, or OPSEC, protects your evasion plan. You should avoid established paths or trails that enemies may monitor. You should also be using encrypted communication channels or silent signals to coordinate. Conceal planning materials like maps or notes to prevent compromise, and brief your team members discreetly and in a limited way to share details to maintain secrecy. Advanced techniques enhance evasion. Terrain analysis for concealment involves studying contours and vegetation on maps to find natural covers like forests or dead space. Understanding your enemy's sensor capabilities allows you to anticipate drones, thermal imaging, or radar and plan routes through areas that disrupt these technologies, like dense canopies. In regard to timing with weather,
You should be using fog or rain or snow to mask movement with infrared or visual sensors. These strategies keep you one step ahead of advanced threats. Evasion route planning is critical for special operations and other covert missions. You should be practicing plotting routes on topographical maps and test them in varied terrains. Watch for challenges like enemy patrols or changing weather and always have alternate routes ready. Combine map reading, compass skills, and terrain awareness to stay undetected. Evasion route planning blends stealth, strategy, and preparation. By leveraging terrain, timing movement, and maintaining security, you can navigate hostile environments behind enemy lines undetected. Navigating across vast distances tests your skills, your preparation, and your endurance, and as the Flannel Daddy says,
I'm going to say it again. If you're not fit, you're going to die.
Welcome to Long Distance Navigation, where we'll learn to plan extended routes, manage your resources, and maintain accuracy over days of travel. Let's master the journey ahead. Long-distance navigation involves unique challenges, specifically like managing resources, maintaining accuracy, combating team fatigue, and ensuring security over extended periods of time. By planning carefully and coordinating effectively, you can cover vast distances safely and efficiently, whether for military missions, backcountry treks, or emergency operations. Planning extended routes requires precision. For route design, you should be breaking the journey into manageable legs by using topographical maps to identify terrain features like ridges or valleys and finding rest points. For checkpoints, you should be marking recognizable landmarks like hilltops or river crossings to track progress and confirm your position. Accurate distance and time estimation is also critical. For the terrain impact, you need to consider steep slopes, dense vegetation, or soft ground like sand, which will slow your movement. Estimate 2 to 4 kilometers an hour on flat terrain, less on rough ground. For your load considerations, recognize the fact that heavy packs will reduce your team's speed, and you should factor in 10 to 20% slower rates for heavier loads. Pace counting and time planning are things that we've touched on in previous episodes, so I won't dive too much into them here, but remember, they do matter for long-distance navigation. Use your map scales and compass bearings to calculate each leg accurately. Resource management sustains long-distance travel. For your food, you should be planning on 2,000 to 3,000 calories per person daily. Prioritize lightweight, high-energy foods. For your water, you should be estimating about 2 to 4 liters per person daily. This depends on the climate, exertion level, and terrain. Identify water sources like streams on maps to replenish your supply. For resupply points, you should plan caches or rendezvous points for food and water to reduce your pack weight. Pack water purification tools to ensure safe drinking from natural sources as well. Resupply points keep your team operational. Pre-position caches with food, water, or gear in concealed locations like wooded areas or dead space. Mark your coordinates precisely on maps and GPS for easy retrieval.
At the beginning of the school year, he had buried a quart jar of pennies underneath his house. He drew a treasure map so he could find them again. A week later, his mom cleaned out his room and threw away the map. Vern had been trying to find those pennies for 9 months.
Plan multiple supply points to account for route changes or delays, and secure your caches to prevent detection by enemies or wildlife. Weather can also disrupt your long-distance navigation. Rain will flood valleys or create muddy trails. Snow or ice will reduce traction, requiring cautious movement and elevating the risk of injury. And fog will obscure landmarks, which emphasizes your compass or GPS reliance. So check forecasts and plan extra time for delays, using maps to identify sheltered routes or campsites. Equipment failure can and will derail a mission, so plan contingencies. You should be carrying backup navigation tools like a spare compass or map, and pack repair kits for gear like your GPS devices or torn or weathered gear. Use redundant systems like plotting GPS waypoints on paper maps, and train in manual navigation techniques like resection to maintain accuracy without tech. Team coordination and morale are also vitally important on these types of adventures. For navigation responsibilities, you should assign roles like lead navigator, a pace counter, or communicator to distribute the tasks among your group. Communication involves using clear signals or encrypted radios to stay aligned, especially in hostile areas. For morale management, you should be scheduling rest breaks, share tasks, and celebrate milestones like reaching checkpoints to keep spirits high. Regular briefings ensure everyone knows the route and the contingencies. Fatigue also has a significant impact on your ability to make decisions. Exhaustion leads to navigation errors, like misreading bearings or miscounting paces. So you should be rotating demanding tasks amongst your group, like carrying heavy loads to manage energy levels. You should be planning rest stops every 1 to 2 hours to maintain focus, and monitor your team's health to catch signs of fatigue early, ensuring clear-headed navigation and maintaining morale. Security is of the utmost importance in hostile areas. So as we've discussed in previous lessons, you should be using terrain masking, avoid predictable paths, move during low visibility conditions, and maintain operational security by concealing your maps and limiting your radio use. Long-distance navigation is essential for multi-day patrols, wilderness treks, or survival missions. You should be practicing planning your routes, calibrating the pace counts, and distributing these tasks amongst your group. All of this requires preparation, coordination, and resilience, and by planning your routes, managing your resources, and maintaining security, you can cover vast distances with confidence.
So there you have it, guys, the complete compilation guide for land navigation. If you guys stuck around until the end, I appreciate you watching. I appreciate your support. And as always, thank you so much for watching, and I'll see you in the next one.